In this section, we will do the installation of OpenShift 4.1 on the AWS infrastructure. As discussed earlier, it will be an installer provisioned infrastructure, that is, the installation program provisions the underlying infrastructure for the cluster. By default, it will configure the cluster in high availability mode. The installation program creates all of the networking, machines, and operating systems that are required to support the cluster. The installation program itself is a binary file. Let's go to the OpenShift installation homepage at https://cloud.redhat.com/openshift/install. Information about the various supported infrastructure is mentioned here. You can select one of the various supported public cloud providers, or you can go for the bare metal installation, or even code-ready containers, which is a replacement of Minishift in release 4 of OpenShift. Anyway, let's select AWS for our purpose. There are options for installer provisioned infrastructure and user provisioned infrastructure. I'll select the installer provisioned one. On this page, at the top, there is a warning about the telemetry data about the cluster, which is sent to Red Hat. In the last video, we already covered in brief what data is sent through telemetry. There is an option to disable telemetry from the cluster, but we will not get into it now. Let's go through the various sections on this page. There is a prerequisite section about how to prepare the AWS for installing the cluster. There is an OpenShift cluster installer. It is a utility that we install on our machine, and then this program does the installation in the AWS infrastructure. There is a secret required for the installation. This secret is for your Red Hat account, and it maps the AWS cluster with your Red Hat account. Optionally, we can customize the deployment as per our need. It is needed if we don't want to go with the default settings and configuration. The next section is to start with the actual installation, and the last one is to access the cluster. Let's understand the installation process before we dive into it. The installer is downloaded on a machine, and it guides us with the installation process. When the installation program is run, by default, it acts as an installation wizard. It prompts for values that it cannot determine on its own and provides predefined default values for the remaining parameters. Three sets of files are used during installation. An installation configuration file that is named install-config.yaml, Kubernetes manifest, and ignition config files. The installation configuration file is transformed into Kubernetes manifest, and then the manifests are wrapped into ignition config files. We discussed about the ignition files in the last section. The installation program uses this ignition config files to create the cluster. You can install either a standard cluster or a customized cluster. With a standard cluster, you provide minimum details that are required to install the cluster. And with the customized cluster, you can specify more details about the platform, such as the number of machines that the control plane uses, the type of virtual machine that the cluster deploys, or the CIDR range for the Kubernetes service network. This is the optional customization section that we saw on the Red Hat installation page. All the customization needs to go in the installation configuration files, which would then be propagated to the manifest files and eventually to the ignition config files. If we do not specify any customization, then the default files are used. For this video, we will go ahead with the default files only. For the purpose of creating the control plane, the installation program first deploys a bootstrap machine. Control plane means the set of the master machines. For booting, the bootstrap machine itself uses an ignition config file that describes how to create the cluster. The bootstrap machine is an ephemeral machine. That is, it is a temporary machine used until the control plane is up. As soon as the control plane is ready, the bootstrap machine is deleted. The control plane then takes the responsibility of creating the worker machines. The worker machines are also known as compute machines. So, bootstrap machine creates the master machines, and the master machines create the worker machines. The master machines make up the cluster control plane, and the worker machines are also known as compute machines. Let's start with the installation now. Firstly, we will configure the AWS account to host the cluster. I will go to the AWS Management Console with the account that we will use for this installation. There are a couple of things that are required as part of this. We must have a dedicated public hosted zone in the Route 53 service, and this zone must be authoritative for the domain. We have whizlabs.awesome.com, which is configured for our account. Next, we need an IAM, administrative user, which is Identity and Access Management. I have already created a user for our purpose. The username is Whizlabs, and this user should have administrator access policy attached to it. We need to create and note the access key ID and the secret access key values for this account. These values would be used when we configure the local machine to run the installation program. Next, we need to download the installer and the client from the provided link. The OpenShift install program is only available for Linux and Mac OS currently. I have already downloaded the required files. I will run the installation from a Linux machine which runs on my laptop as a virtual machine. The client and the installer are copied over to the Linux machine. I have just extracted the files. We can copy the OC client and the kubectl client to the user bin directory or just add the current location to the path variable. This will be needed once the installation is done. Okay, so I just moved the binary files to the user bin directory. We also need to download or copy the secret. The installer program will prompt you for your pull secret during installation, and this will authenticate to your Red Hat account. It is used to authenticate with the services that are provided by the included authorities, including Quay.io, which serves the container images for OpenShift container platform components. I have already downloaded the secret. Next, we need to configure SSH private key on the local installer machine. The key should be configured for passwordless authentication and will be used to connect to the master nodes during the cluster install process. I'll create a key using ssh-keygen. Algorithm will be RSA and blank password. We will specify the path and the file name for the key. So the key got generated. Next, we need to start the SSH agent process as a background task. We need to add the private key to the SSH agent. We'll use the ssh add command and the path to the key. So identity got added successfully. The public key would be automatically copied over to the master machines during the installation. I will now create a directory to store the files created by the installation program. We should ideally specify an empty directory because some installation assets like the Bootstrap X509 certificates have short expiration intervals, and they might cause issues if they are pre-existing and already expired. We are now ready to run the installation program. So let's start it. We need to run the binary OpenShift install, provide the option to create cluster, specify the installation directory which we have created, and set the log level as debug so that we understand what's really going on. I will now select from the options. The platform will be AWS. I'll select the region as US West 2, which is Oregon. The base domain will be whizlabs.awesome.com. Let's provide a cluster name. I'll just say Whizlabs. And I will now copy the pull secret. Just pasted the secret, and now the installation is progressing. It will take some time for the installation to finish. I will just fast forward through the process. At this moment, we can see that there are 4 running instances. One is the Bootstrap machine, which is in running state, and we have the 3 master machines. The installer is now waiting for bootstrapping to complete. And now the bootstrap machine is being terminated, whereas the workers are being initialized. So now the installation is complete. The URL to access the cluster is provided here, also the username and the password. If I just go to the AWS console right now, we'll see that there are 3 master nodes, 3 worker nodes, and a bootstrap machine which is now terminated. Also, if I go to Route 53, there are now 2 hosted zones, and this is the one which is created by the installer managed by Terraform. A quick review of the installation steps. First, we need to configure the AWS account to host the cluster. Then we downloaded the installer and the client onto the machine from which we'll run the installation program. We need to download or copy the secret for our Red Hat account. We need to configure a SSH private key on the machine from which the installation will be run. We need to create a directory to store the files which are created by the installation. And then we had started the installation program. Let's access the cluster. Write the username as kubeadmin and the provided password. So the message says that we are logged in as a temporary administrative user and we need to configure the OAuth for the cluster. We will do this later. So these are the default projects created in the cluster. Just go to compute, nodes, and here are the 6 nodes which are part of the cluster. If we check the cluster status, the health of all the components is good and the control plane status is also up. Through the command line interface, we can log into the cluster as a default system user by exporting the cluster kubeconfig file. We can access this file by running cat, the installation directory, auth, and the kubeconfig. The kubeconfig file contains information about the cluster, which is used to connect to the correct cluster and the API server. And the kubeconfig file is specific to a cluster and is created during the OpenShift installation. We will export the kubeadmin credentials by running the command export kubeconfig and then the path to the kubeconfig file. I'll run the oc whoami command now. It says I'm already authenticated to the cluster with system admin credentials. So that's it about this section. We were able to create the OpenShift cluster on AWS infrastructure using the installer provision infrastructure option and the default settings for the cluster.